Very well, so hopefully that was easy, right? I already implemented and I already copy and pasted here, so this is my implementation. Should be kind of similar to what you did. Just keep in mind that the way that I'm finding, the updating of this nearest section of the ship means that I'm gonna have, again, a current section that is going to visit, right? We're gonna have a loop, and I decided, right, instead of doing that do while loop, I know that I just want to visit let's say, the 4 sections ahead of me, right? So I have to always look ahead of me in our simplified version, right? That we decided that we only want to render the things in front of us. I am always looking the 4 sections ahead of me. So I start the current with the current closest one, and then minimum distance 99999, and then for I between 0 and less than 4, I++, so I only go 4 sections ahead of me, current equals current next. And what do I do for these 4 sections? Well, I check the distance, right, between the current center minus the ship object's position, Vx, so the distance between the track section and the ship position, the current position Vx, and then I do that for x, y, and z. So in other words, I get the distance between the ship position and the current section that I am visiting in this loop, and then I get the distance magnitude, same thing, square root of x squared, y squared, and z squared, and then if the magnitude of the distance is less than the minimum, I found a new minimum, and I update the minimum distance, and I also update the ship section with the current one, because I know that I have just found a closest section than the previous one that I had. Only 4 times, because I just want to check the 4 sections that are ahead of me. Always, like I said, trusting that whatever order that came from the file is exactly the order that I am visiting these things, right? One per one. So my linked list should have all the sections in front of me. They are the next and the next and the next and the next. So I'm just visiting the 4 next ones, checking and seeing if I have now a closest one than the previous one that I had. And if that is true, my ship section is updated with the current one, which is now the new closest one. And just to make sure that we are really computing things and updating correctly, closest section to the ship, I'm just printing again the ID of the closest one, which I hope I already compiled, so we should see as we are right now, it says that the closest section is section number 12, but I hope to, as I am moving, I hope to see now 13, 14, do you see 15, 16? I have all these sections here being updated, 21, 22, 23. So we are updating the sections as we are moving through the track. 38, 39, 40, and as you would expect, the ID of the sections as they came from the file, they are really the ones, right? One by one, as we are moving ahead of the track, as I'm moving forward, my sections get updated in the correct order that I'm looking at them. Does that make sense? So that is it, right? I just wanted to make sure that we have all these sections correctly being loaded. Now we have 123, 125, 126. As I am moving forward in the track, I get those sections being updated one by one, right? So I have always, inside my ship, I have always the closest, right? This ship section is always the closest section that I am right now navigating through the track. So as I move through the track, this ship section always gets the closest one. And that is going to be super useful because now in the next lecture, we are going to go and based on the current section that I am, I don't have to do all those distance checks. If I am in the section, all I have to do is render the ones in front of me. And that should be as easy as just going a while loop, 30 sections or 40 sections, as many sections as I want to see ahead of me. All I have to do is just loop, next, 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 in my linked list, and just go and say, render this section. No more distance check, no more checking if we are in this visible radius. Everything is being done in the linked list. I just go, I loop, and I render that section. Do you see, this is something that I want to talk to you about. Do you see how we have to delegate? We have to think about start delegating stuff I don't want to start computing things per frame. And if I can pre-compute those things before and have them in a file, right? So if I pre-computed them and they are already in a file, and I guarantee that the order that the file is loaded and saved is the order of the tracks and sections one after the other as I navigate them, that saves us computing time, right? So that saves us from having to compute everything one and again and again and again every frame. I already pre-computed everything before, right? So those things were already pre-computed for me, saved in a file, and the order of the file is now benefiting us, right, from having to compute all those things again and again and again. This is a pattern that you're going to see a lot with games like that, right? Since we don't have a super fast processor compared to what we have nowadays, right? We have all this extremely fast processor with gigahertz and gigahertz of processing power, right? So we don't have as much processing power as we have in modern games. So if we have these limitations, if we want to squeeze a little bit of performance, how about pre-computing stuff, saving this pre-computation in a file? Because if I pre-computed those values, then I don't have to compute them again frame per frame per frame, right? This is a pattern that you're going to see a lot. So as you're going to see, in the Wipeout assets, all these assets, they will have these pre-computed things inside. So they found a way of pre-computing values so we don't have to go and waste time. I wanted to talk to you about that because this is something that you're going to see in the way that we are approaching, rendering tracks, rendering objects, computing the distance of these objects. What objects are visible? What objects do I render around me? Well, you're going to see that the same way that we have these tracks already pre-computed, we're going to have per section, we're going to have a list of objects that are visible per section. So we don't have to do the distance check per second. This is something that is going to, we're going to see this again and again and again. Pre-computing stuff so we don't have to waste processing power per frame, right? So this is frame per frame. If we can save a little bit of processing power in this hot code per frame, that is a huge deal for us. That is really good news for us.